Okay, so this video is going to instruct you on how to perform a Fisher's LSD protected t-test following one-way ANOVA. And Fisher's LSD protected t-test is used in a kind of a limited scenario where you just have three comparisons that you want to make after the ANOVA test, the omnibus test. And that's if you have three groups, then there are only three comparisons that are possible, right? If you have group A, group B, group C, you can compare A versus B, A versus C, and B versus C, and that's it. If you have more than three groups, then there are more possible comparisons that you can do. You may determine, however, that there are only three comparisons that are meaningful to you, just from a research standpoint. And so you may still be able to whittle that down to three comparisons, and then you could still use this test. Otherwise, you need to do something else if you need to perform more than three post hoc pairwise comparisons. Pairwise meaning that you're doing a comparison between just a pair of groups. You have three, but you can select three different pairs. Okay, so in this case, let's say we just have three groups and we want to compare all three. So we first need to run the ANOVA single factor function in the data analysis tool pack. That's pretty straightforward and explained elsewhere. Once you've done that, then you need to build this formula manually in Excel. Unfortunately, Excel doesn't have a point-and-click formula to run this test. Other statistical packages do have something more like that. But once you build this, at least you can copy and paste the formula and kind of reuse it. So what these symbols mean, x bar 1, this is the sample mean from whichever one of the two groups that you want to compare. X bar sub 2 is the other one. Remember the square root sign over the whole thing here. And the denominator, ms error, is this value right here, ms within groups. Expand that out. Ms within groups. And then N1 is sample size for the one group, and N2 is sample size for the other one. Okay, so let's do A versus B first. So it's a little bit hairy to build. We actually have the average for group A right here. It's in the output. We're going to do subtraction, and then group B, select the average for that one, and close up those parentheses. Okay, and that's important to close those up because order of operations. If you don't have those, it'll mess up your result. Okay, and then put some parentheses here in the bottom. Square root of the whole thing here, and then we need to make sure we select the ms error value here. Do a times symbol. Okay, there's a multiplication here, but Excel doesn't treat it as a multiplication if you just put them right up next to each other. You have to put in that little star asterisk symbol, and then you do these parentheses 1 divided by n1. That's actually in here as well. You can select that. And you don't need to put parentheses around that one because the division takes place first anyway, and then 1 divided by the other one here. Since these are round whole numbers, you could just type in 12 instead of selecting that, but it's always good practice to select a computed cell in Excel rather than typing in a number manually. Okay, and then you just close up the parentheses. We have three. Okay, the purple, the red, and the black. And then that should give us the correct result. Okay, 5.55, etc. Now, notice this is negative. Sometimes you'll get a negative, sometimes you'll get a positive. What's the difference? Well, it just depends on which of the groups that you select first here, and it doesn't matter. And you may have a certain reason for framing your results as a negative, as like a negative difference, a lower. This group is lower than this one or something. As far as like entering answers into homework, it'll be graded either way, correct. So that's how you do that one. Now, if you want to get the p-value associated with it, you use a formula called t.dist.2t. Okay, so this is an Excel formula. It's pretty handy. You can just give it a p-value, or give it a t-statistic, give it a t-statistic and a degrees of freedom, and then it'll give you the p-value. Now, one catch is that it needs to be a positive number that you put in here. It won't handle negative numbers. So actually, let's kind of swap these around so that we get a positive. So let me just show you how that goes. Let's put that one back now. I think that's it. There we go. Okay, so same number is just positive now. So here's the t statistic, and then the p-value we'll put here, so t.dist dot 2t, and then we put in this number for x, comma, degrees of freedom. Now, what are the degrees of freedom? It's actually the degrees of freedom associated with the MS error. Okay, so you can just select that df there, close the parentheses, and there's our p-value. And yeah, it's also very small, so and that kind of makes sense. You can look at these averages to make sure this passes the stink test. 7.5 versus 2.41. Yeah, we'd probably expect those to be different. And then the critical values, sometimes this is kind of handy. You've done critical values before. That's t.inv.2t. This time you put in a probability, and it'll give you a degree and degrees of freedom, and it'll give you a t statistic. So you can put in 0.05, that's typically what you want to do, and then degrees of freedom again is degrees of freedom associated with the within groups. And so in order to reject the null hypothesis for this particular comparison, A versus B, the critical value would need to be 2.03. And since the degrees of freedom are the same for all of these comparisons, this critical value will be the same for all of these. We only need to compute it once. Now, here's the little trick. If you just hit Control-C and then Control-V here, right now it's barking at me because the inputs are off, but if you double-click, I don't need to do that big hairy formula again. I can just kind of scooch these up. We're doing A versus C, so I'll move those up. There maybe is an advantage to just typing 12 here, so, since the groups are all the same size, so you don't have to move those around. But yeah. And then the MS error, make sure you always select that. Okay, so there's our t-stat for the A versus C comparison, and just to round this out, let's do B versus C. So group B versus group C. Change the inputs there and change the input there. So now that by the way, now that we have the critical value, we already know that 2 of these are statistically significant, while the other one is not. This one does not meet this threshold. It's not greater than that, while these 2 are, or at least they're more extreme, right? Even though they're not absolutely larger, because one is negative. So, you could write this up in a result saying Group A had a significantly lower average than Group B, and Group C also had a significantly lower average than Group B. However, A and C did not differ by a statistically significant amount or something like that. Okay, so there's Fisher's LSD protected t-test.